Sir,
Yeah, tell me.
sir, I have a doubt in one of the miscellaneous exercise of derivatives.
What is it?
One problem, sir. I don't know, like how to prove it. I don't know how.
Okay, what is it?
So can I paste it in that chat, sir?
Can you say 1 minute? 1 minute. I will try it. No, I didn't understand. Yeah. Tell me what is it? Y is equal to e power.
So e power a cos inverse x.
Okay.
So x lies between -1 to 1. Show that show that 1 minus x square
Okay.
into double derivative minus x into single derivative minus a square y is 0.
How to do this problem? So one thing, if you directly start differentiating, you will get stuck. Okay. So first step, y is equal to e power a cos inverse x is there. No, you take log on both the sides in the first place. So when you take log, you will get log y is equal to a cos inverse x. Okay. When you do this, you will get 1 by y into y dash is equal to a into cos inverse x is minus 1 by root of 1 minus x. Okay. So y dash will be equal to a into y divided by root of 1 minus x.
Minus a.
Is it right?
So minus a into y.
Okay. Now what I can do is root of 1 minus x square into y dash, I'll write it as minus ay. Okay, let me call this as equation number 1. If I start differentiating this, what will I get? 1 by 2 root of 1 minus x square into minus 2x into y dash plus 1 by root of 1 minus x square into y double dash is equal to minus ay. 2 and 2 are gone. So minus x divided by root of 1 minus x square into, in the place of y dash, can I write it as minus ay divided by root of 1 minus x square? Plus y double dash divided by root of 1 minus x square is equal to minus ay. that right? Did you understand what I did? Okay. So this becomes axy divided by 1 minus x square plus root of 1 minus x square divided by, right?
Sir,
Yeah,
sir, I think you made a mistake in the second last steps.
what is the problem?
Sir, actually, in the second last step, the root over 1 minus x square would be in the numerator, right? Multiply with y double dash.
Ah, that's right. Okay. So I'll get minus xy dash plus, if I take LCM, I get 1 minus x square into y double dash is equal to minus ay into root of 1 minus x square. Is this right?
Yes, sir.
One minute. Okay. Minus xy dash plus 1 minus x square into y double dash is equal to minus. So I think we almost got the answer. Right. So 1 minus x square into y double dash minus xy dash is equal to minus ay into root of 1 minus x square. So how to prove that root of 1 minus x square? So if I'm able to prove that root of 1 minus x square is actually a, then I got the answer. So this is what they asked, 1 minus x square into y double dash minus xy dash is equal to
Sir, it should be minus a, right?
that's what maybe this root of y into 1 minus root of 1 minus x square can give us, sorry, root of 1 minus x square can give us a minus a. But is there a step where I'm able to find it as minus a is what I'm checking. You're coming now only from school. Okay. There is a problem with the tab. I can't find where I went wrong. So 1 minus x square into y double dash minus x square dash. So log y is equal to, let's check the steps again. Log y is equal to a cos inverse x. So 1 by y into y dash is equal to a into minus 1 by root of 1 minus x square y dash is equal to minus a y divided by root of 1 minus x square. So root of minus x square y dash is minus a y. Yes, there is a mistake here. There is a y dash. Guys, did you understand? You didn't understand.
The differentiating on both sides, sir. So
I
minus
differentiated on both the sides. No, I concentrated only on one side. See, in the UV apply 1 by 2 root of 1 minus x square into minus 2x chain rule into y dash plus root of 1 minus x square into derivative of y dash is y double dash. I actually wrote in the previous step as minus a square y. But what should have actually come? A square y dash. But I already know what is the value of y dash. Y dash evo. So y dash, I know it is minus ay divided by root of 1 minus x square. Is that right? How? Y dash is minus ay divided by root of 1 minus x square. I substituted here. We got the answer actually. Okay. So 1 minus x square into y double dash divided by xy dash divided by root of 1 minus x square into a square y divided by root of 1 minus x square. 1 minus x square, 1 minus x square gone. So 1 minus x square into y double dash minus xy dash minus a square by 0. I hope you understood. Nitish, you got it?
Yes, sir.
Yeah. So the mistake was at that place, y dash. Right. Yeah. Shall we proceed with the last part of determinants? So what did we see in the previous class? Can you tell me the last point where I stopped it? I remember explaining you what is adjoint of a matrix. What is adjoint of a matrix? Transpose of the cofactor matrix is called as adjoint, right? So there are two important points we discussed. One is minors and the second is called as cofactors. What are minors basically? Minors are determinants. Minors are determinants obtained by eliminating the corresponding row and the corresponding column of that element. Then what is cofactor? Cofactor is minus 1 power I plus j times minor of that number. Right? So adjoint speaks about the cofactor matrix, not the minor matrix. So write the cofactor of the given cofactor of all the elements in the given matrix and find the transpose of it. Then you name that matrix as adjoint. So why is adjoint important? Adjoint is important for us to calculate the inverse of a given function. Sorry, given matrix. Okay. So when can you find the inverse of the matrix? First thing when it is a square matrix in the first place. And the second most important point is it should not have the determinant to be 0. So there is a point I need to mention. If there is a matrix whose determinant is equal to 0, you call this matrix as singular matrix. Similarly, the determinant of a matrix is not equal to 0, you call it as a non-singular matrix. Is it clear? So, first thing is for you to find the inverse, you need to have a square matrix, and for that square matrix, you will be able to find the adjoint. After you find the adjoint, you divide that adjoint with determinant of A, and the determinant of A should not be equal to 0. So matrix should be a non-singular matrix. So even before you proceed with this method, first thing you need to verify is find the determinant. Seriya? Shall we try a problem and see? Did we do this problem in the previous class? Did we do it?
So we only found the adjoints and not the inverse.
Okay, find the adjoint again. So what is the adjoint? You found the transpose? 7 minus 5. 7 minus 3. Minus less 1 0. Okay. So since you have found this, find the determinant of A also. As I told you, the first step is find the determinant of A. So
Sir,
determinant
it's
of A.
1.
Okay. Then A inverse will be equal to adjoint of A divided by det A. Okay. Is that clear? So that value will come out as 7 minus 3 minus 3 minus 1 1 0 minus 1 0 1. Is that clear? So this will be the inverse of the matrix. Okay. But they asked us to verify something. So once you find the adjoint of A, okay, once you find the adjoint of A, multiply A and adjoint of A and tell me what is the answer. Multiply A and adjoint of A and tell me what is the answer. It's an identity matrix. So A into adjoint of A, you should get it as 1 0 0 0 1 0 0 0 1. Are you getting this? Yes. Here. Now, for the 25th one, find out what is A and B. A and B are given, both are square matrices. Find the product of AB and take the inverse of it. Then find B inverse separately, A inverse separately, and multiply both and see. If they both are giving you the same matrix, then the answer is right. So what is AB? So 2 minus 3 minus 4 plus 9 1 plus 5 minus 2 minus 7. How much is it? Minus 1, 5, 6 minus 9. Is this right? So minus 1 plus 4. Is it fine? Minus 1, 5, 5 and minus 1. Right. So how will you find AB inverse? AB inverse is
Sir. Sir, it'll be minus 14, right?
1 minute. 1 minute, wait. 2 minus 3 is okay. Minus 4.
Sir, instead of minus 9, it should be minus 14, sir.
Okay, 1 minute. So this is right. 1 plus 4 minus 2 minus 2. So AB inverse is adjoint of AB divided by the determinant of AB. So adjoint of, so even before you find the adjoint, find the determinant of AB. Determinant of AB is 14 minus 25, which is minus 9, minus 11. No? So 14 minus 25 minus 11 is the determinant, which is not equal to 0 since it is a non-singular matrix. Right? Now we can proceed with the next step. Okay. So what is the adjoint of AB? 14 or minus 14? Yeah, 14. It is minus 14.
Sir, it's minus 14, right?
Yes, minus 14 minus 5. Minus 5 and minus 1. Okay.
Sir, actually, it'll be plus 5 and plus 5. Right?
Plus minus. Correct. See, this is A11. This is A12. So 1 plus 2 is 3. So minus 1 power 3 is minus, so minus 5. Similarly for 3, 2, 1, this will be minus 5. And this will be minus 1. Check it. Minus 14, minus 5, minus 5, minus 1.
Yes, sir. Yes, sir.
So you can actually take out that minus sign. So you can write it as 14, 5, 5, 1 with the minus sign divided by minus 11. Minus and minus are on. So you will get 14 by 11, 5 by 11, 5 by 11, 1 by 11. That's it. Here. So this is what is AB inverse, but what did they ask us to verify? Find out whether AB inverse is equal to B inverse times A inverse. So find B inverse separately, find A inverse separately, multiply both. The only thing is you need more concentration. Do it fast.
So, do we have to find P inverse dot A inverse or A inverse dot P inverse?
Now you have to find B inverse into A inverse because the inverse of AB is equal to B inverse into A inverse. That is actually a property, like how you do for transpose. AB transpose is equal to B transpose into A transpose. So same is the case with inverse also. Because in inverse also you are taking the transpose. Matching. So what is B inverse? 3, 2, 1, 1. What is A inverse? So B inverse into A inverse now, I'll have 12 by 11 plus 1 by 11. Sorry, 2 by 11. 9 by 11 minus 4 by 11. 4 by 11 plus 1 by 11. 3 by 11 minus 2 by 11. So this will give you 14 by 11, 5 by 11, 5 by 11, 1 by 11. This is what is. So this is also equal to AB the whole inverse. Is it right? Now, 26. Show that the matrix A is equal to 2, 3, 1, 2 satisfies the equation A square minus 4A plus I. So your job is very simple. Find all the three terms separately. Matrix A is given to you. Find out A square. A square means what? A multiplied with itself. Tell me what is the answer for that. So write down the equation A square minus 4A plus I. A is 2312. A square minus 4A plus I will be equal to 0.
A square is 7, 12, 4, 4, 7.
What is 4A?
3, 12,
I is obviously 1001. When you add, you should not add everything. Now you can add. Now you can add everything. Because previously I wrote 4A. No. So A square minus 4A plus I. When you add everything, what are you supposed to get? 7 minus 8 is minus 1. Minus 1 plus 1 is 0. 12 minus 12 is 0. 0 plus 0 is 0. 4 minus 8 is 4. 4 plus 0. Sorry, 4 minus 4 is 0. 0 plus 0 is 0. 7 minus 8 is minus 1. Minus 1 plus 1 is 0. So that gives you a 0 matrix. Okay. So in some of the problems, they will extend by saying, you first prove this. From this logic, you find out what is the value of A inverse. Means you should not go with the adjoint method, rather you have to use this equation to get that particular output. So for example, they have asked in this, Using this equation itself, find A inverse. Okay, how to do that? So first thing is you need to understand the determinant of A is not equal to 0. So what do we have? A square minus 4A plus I is equal to 0. So what we will do is we will multiply with A inverse on both the sides. So when I multiply with A inverse on both the sides, A square A inverse minus 4A into A inverse plus I into A inverse is equal to 0. Right? A square I can write it as A into A, that other A is multiplied with A inverse, minus 4 into A inverse plus I into A inverse. Is that clear? So what is A into A inverse? That is I minus 4I minus I into A inverse is equal to 0. So what is A into I? A minus 4I minus A inverse is equal to 0. So what is A inverse, guys? A minus 4I. So A inverse is A minus 4I. So you already know what is A, you already know what is I. Find out A minus 4I and that will give you the answer.
Sir, how did I into A inverse become minus A inverse?
Oh, sorry, plus. Plus only, sorry. Then A inverse will be equal to 4I minus B. So A inverse will be equal to 4I minus B. So can we do the exercise? Yeah, can we do the exercise, guys? Can you go a little fast? So find the adjoint of the matrices in exercise 1 and 2. So it's a 2 cross 2 matrix. It is easy for you to find it. Find it fast. 1, 2, 3, 4. See, I'll tell you how for a 2 cross 2 matrix, right? how to write the adjoint in one step. See. Listen. So when you're finding the transpose, right, generally what happens? So first, for 1 and 4, what would be the cofactors? Generally, when you take the diagonal elements, right, the diagonal elements will take the same number, 1, 1, 2, 2, 3, 3. So when you write minus 1 power 1 plus 1, or minus 1 power 2 plus 2, or minus 1 power 3 plus 3, everything will give you a positive value. So what you can do is, for the diagonal elements, just swap the values and write it. That is 4 here, 1 here. Okay. Now swap the other two elements also, 3 and 2. Is that clear? So for the elements which are coming in the rightward diagonal, so that's not generally not called a diagonal, but if you take it as a diagonal from the right hand side, there the sign will be different. So change the sign there, that will give you the answer. But for a 3 cross 3, you can't do it like that because you need to find the determinant. One minute, sorry. This is the adjoint. Adjoint on this one. So what I have written is actually cofactor. I'm sorry. What we have written is cofactor matrix. So adjoint kennapannu. You need to again take the transpose of it. So minus 3, minus 2. Am I clear? So how to write the cofactor? First, leave the diagonal elements from left to right as it is. On the right to left, find the transpose. Okay, and change the sign on it. So 1, 1, 2, 2, 3, 5, 2, 1, 0, 2, 0, 1.
Second, 3 minus 1 minus 1.
So adjoint is okay.
8 minus 3 minus 6 4. Six minus 3 minus 4.
Now adjoint get later on. They're asking you to verify A into adjoint of A is the same as adjoint of A into A is the same as delta into Y. Is there anyone struggling with this? Are you able to do? Niranjan, you? Amrita?
Zero.
Zero.
Zero matrix. A into adjoint is zero matrix. Adjoint A into A is zero matrix.
Zero matrix.
Determinant A is
Number determinant of A is 0. Correct. More also rains are expected. More also rains are expected. After that. Yes. None of you have. Hey, those who are online, what are you people doing? Are you solving the problems? So listen, find the inverse of each of the matrices. இருக்க வாங்கிட்டு வந்துச்சு இங்க ரெண்டு வீட்ல அப்புறம் அந்த இதோட மெஷர்மென்ட் கூட எடுத்துக்கோங்க விண்டோ ஆல் சோஃபா ஓகே find the inverse of each of the matrices. If it exists means what? When will it not exist? When the determinant of A is equal to 0, it will not exist. So when it exists, find the value of inverses. Can you do it fast? So do that, find the adjoint, find the determinant, divide both. Finished? How many problems are over?
Minus 3 by 2, 1, 2, minus 1.
Is it right? For first one, fifth one, right? Minus 3 by 2.
1,
Okay.
2,
Okay.
minus 1.
Is it right? This is what everyone got? Online base. Is that right answer? $14. Is an as a number right 2 to 4 Priya or 2 minus 2 4 Priya? Illa, question is right. 2 to 4 3 then. 2 minus 2 4 3. So what you did is right only. It is not his mistake. Then in 14 I got it out. I'm cross multiplying 6 and this side I'm having 8. I need to add both. So one of the numbers should have been minus. So what you did is right. If it is minus,
Three by 14 minus
third up 3 by
2 minus 2 by 2 minus 4 by 2 2 by 2.
This is right. Reverse, sir. Oh, question very nice. They are not even close. Not even one number is matching. Sixth one, okay. This is the question 1532. Adon tappa. Seventh one is correct. Okay, still their numbers only right. D2. But if you see, all the models are already covered. So we saw this one also, no? AB inverse is equal to B inverse into A inverse, that model we have seen. Similarly, when you have an equation which is equal to 0 matrix, from that you need to find the A inverse, that also we have seen. So the only problem that is new is 14th one. 14th one, they have given you a 2 cross 2 matrix and they have given you an equation of A square plus A into capital A plus B into capital A is equal to 0. So from there, find out small a and small b. That you can do it. So what you will do, A square, multiply small a with capital A, then multiply b with I. When you do that, right hand side will be 0, 0, 0, 0. Left hand side, you will have a matrix. Okay, when you add this one to this one to this one, you will have one matrix. Compare the coefficients that will give you the value of A and B. I hope you understood no? That you can do it. Similarly, 15th one you can do it. 16th also you can do it. Okay. So remaining problems you can try. This is there, no? Applications of determinants and matrices. So this part you will see tomorrow. But before you do this, you need to master adjoint and find the inverse, because they say the applications of determinants of matrices, right? So determinant and matrix both are used to find inverse. Adjoint or the matrix are. Determinant is determinant. So the combination of both is what is inverse. So you need to master both of them. Only then we will be able to solve these kind of problems. Basically, what you will do is, you remember in the beginning of the chapter, I told you, why do we study determinants? To solve simultaneous linear equations. So when you want to solve linear equations in 2 variables or 3 variables, one of the methods that we can use is a cross multiplication method. So when you use it, you see everywhere you have those things only. We'll be solving them all of them. Is that clear? So remaining problems, can you try and come before tomorrow? Try it sincerely and come. Good. So any other doubt? Those who are online, any doubt, guys?
No, sir.
Those who are online, any doubt? Clear, no? Okay, then we'll wind up.